In this video, I want to talk about how the AI characters in Agents of Mayhem traverse the environments. Because of the verticality of our combat spaces and their relative urban density, all AI characters were given rocket boots for keeping pace with the player. Two systems were created to facilitate characters traversing nav mesh user edges. User edges define breaks in the nav mesh where cover or abrupt changes in elevation are present. The first system I prototyped involved blending animations with exactly the same timing and start positions, but end at different heights. These were plugged into a simple blend tree with the goal height driving the weight of the blend. And aside from a bit of technical adjustment for correction, the animation data itself drove the look and feel of the system from start to finish. The other system that was used involved moving characters between predefined pairs of user edges. Based on ranges I felt would scale well in our environments, when our nav meshes were generated, we had user edges that shared similar angles paired up. Each user edge could be paired as many times as the conditional criteria was valid, but the value of pairing meant that AI could pathfind across those pairs as though their path were never interrupted. The challenge here would be in moving characters between those positions and have them look good while doing it. To ensure complete coverage of the paired edge range, I used a blend tree with 6 animations: near and far high, near and far level, and near and far low. As long as each of these motions shared the exact same timing, characters should have no problems reaching their desired goal positions. The first set of motions I created carried characters past their intended positions. This was actually done on purpose to see how much freedom I really had when creating these motions. As it turns out, there was not all that much freedom to be had, as this led to a variety of issues, one of which was the dreaded AI character off nav mesh. So a second set of animations was created to move characters exactly between their start and desired goal positions. But because the first set of motions were a big hit among people playing the game, our AI programmers would run a check at the goal position to determine if there was enough runout space for the first set of animations to be used. In the end, the final blend trees that were used in-game differed a bit in what I've described here, but the core idea was the same: a data-driven solution that would allow animators to fully control the look and feel of the motion without relying too heavily on a technical solution that could alter the timing of their work.